Today we're going to do our cell respiration lab. It's a lab for us to check out how well you guys can quantify your respiration rate. So we studied cell respiration for a while. Today we're actually going to be able to see it. So before we get started, I want to make sure that you guys know what we are going to take a look at. So I need one reactant for cellular respiration, just a single reactant, one of them, just one. Bryce, what do you think?
Oxygen?
Oxygen as a reactant. Yeah, we need oxygen as a reactant. Good. How about another reactant for cellular respiration? Jillian, what's another reactant for cell respiration?
Glucose.
Glucose would work fine. We could use any other food kind of molecules used, but for the reaction that we're studying, glucose would be an excellent reactant. How about a product? One product of cell respiration. Just one product. Food. Anne-Marie, what do you think?
ATP. Energy.
Okay, ATP and a form of energy would work. That's good. How about another product of cell respiration? Ryan, what do you think?
Water.
Water. Okay, excellent. And the last one. All right, Thomas, get it.
Carbon dioxide.
Carbon dioxide. Very good. Now, for some of these, it's really easy to see. For some of them, not so much. So one of the things I think is easy for us to see is that water. We could condense that water on something. If you wanted to, you could get close to your table and go and see if that water's there. You don't have to do that, don't freak out. You could do it on your sunglasses or on your DVD or something like that. But we can see that water pretty easily. The energy is also pretty easy to see. If you don't eat, you're kind of tired. You need some energy. But the carbon dioxide is not so easy to see, and that's what we're going to look at today. So we're going to use a situation where we're going to perform a titration to look for carbon dioxide produced. Now my last bit. Carbon dioxide, when dissolved in water, forms a pretty awesome substance. I want you guys to write it on a board. Grab a board. I want to know what carbon dioxide dissolved in water forms. And you guys know this because you looked at the procedure for the lab. You guys have seen that. I gave that to you yesterday. You know what we're about to do. Look in there if you're confused. As soon as you know what is formed by dissolving water into carbon dioxide into water. Write it up there and hold it up. Up. I'm still waiting on a couple people. Very good. Some people are writing the chemical formula. Some people are writing the words. I don't mind. Waiting on Julian, Hallie, Allie. Gio is writing a dissertation. Okay, good. The formula and what it's called. Excellent. Okay, guys, look around. Everybody's got carbonic acid. You either have H2CO3 or carbonic acid. Fantastic. Now, last bit. Our titration involves an indicator that will show us a basic situation. So, if we put our indicator into a base, it turns that color. This indicator, this phenolphthalein, shows this as basic. If we need to make something basic, we add a base to a solution. And the base that we're going to utilize here is sodium hydroxide. If we have water, this is just water, and we put a drop or two of this indicator in, if it's basic, it should show us that color. Put some drops in here. This water, because West Palm's doing such an excellent job, it's just slightly basic. It's just a tad pink. It doesn't match our controls yet, so what we need to add is just a little bit of a little bit of sodium hydroxide, and it should achieve the color of the control. And right there, a few drops of sodium hydroxide. It looks pretty good. And so we're going to use this colorimetric analysis to determine how much carbonic acid we can get in there. How are we going to get carbonic acid in here? All right, Bryce, you look excited. Why?
Because of the carbon dioxide we breathe out.
Fantastic. So if I blow into this, and I am getting carbon dioxide into it, it should no longer be basic because of that carbonic acid. It should be acidic. If it's acidic, what color is this going to turn? Julian?
Unclear.
Let's see. I think it works. So now how are we going to determine how much carbonic acid we just got in there? This is the quantitative portion. How much carbonic acid? We want to quantitatively be able to analyze that. Gia, what do you think?
We're gonna put phenolphthalein in there.
Drop by drop, and that's going to tell us how much carbonic acid was in there. So now, if I just blew until it turned clear, is it going to take as much sodium hydroxide in here as it would take if I blew in there for the full 30 seconds? No, it won't, because there'll be less carbonic acid. And there, at 30 drops, I think it shows us how much is there. All right, guys, before we get started, you guys all have safety goggles, you all have aprons, you read the procedures, we are ready to go. Get with your mitochondrial mates, and let's start this thing off. It is exciting. All right, guys, also, you're going to add the data that you get for these 3 trials at rest to your data table 1 that looks just like the data table up on the board. So, if you guys have not constructed this data table yet, please do so. You need 2 columns, trials at rest, trials at exercise. If you guys need paper towels, we have quite a few over here. And I'll bring some around to you guys at your tables so that you have some in case of spills. Definitely want to make sure it matches this control. Does that match the control? You got 2 options. One option to make it match the control. Well, which? Okay, you can do that. Doesn't matter. Or you can do what? I love the sound of everybody blowing bubbles at the same time. It's like a chorus of harmonic bubbles. And again, guys, here are some paper towels. If you spill anything, just let me know. You can wash up real quick. Paper towels are useful. If you need another straw, because yours dropped on the floor, so let me know. And as for timing devices, you can use your watch like we just heard, or the clock. I don't mind if you use your phones just for a timing device if you need it. Okay? Uh-oh. You need to get some water in there. Drink it, idiot. Okay. In terms of your experimental start.
Yeah.
Right, so going first trial?
Yeah.
Just to get you another cup. Yes, ma'am. Sure you do. Again, guys, don't forget to record the number of drops in your data table. These will be for trials 1, 2, and 3, or at the rest.
It looks great.
So we don't shake it
I think
or
it's probably more relaxed, right?